This is Honors Algebra 2 Pre-Calculus. We're doing Chapter 10 in Pre-Calc, which is conics. So we're going to talk about circles in this video, which is not actually an entire section in the conic part of our book, but it's important to know the formula of a circle because it's going to come up. It comes up in calc. It comes up in geometry. So rather than just hand you the formula of a circle, which I know I could hand it to you and you could look it up, we're going to use a formula that we already know, sort of two formulae that we already know, to figure out the formula for a circle. So the idea behind a circle is that it has some center. Now we're going to call that center h comma k, right? And it has some fixed radius, r, such that every point on the circle, right, this edge that is terribly drawn, but just bear with my inability to draw a circle, every point on this circle, x comma y, should have a distance of r to get to the center, right? So let's use the distance formula, which is sort of really just the Pythagorean theorem. Let's talk about how we could find the formula for a circle. So if this is the x-coordinate h, right, and this is my x-coordinate x, right, some arbitrary x that's on the circle, and if this is my y-coordinate k, and this is my y-coordinate y, some y on the circle, I would argue that I can find the distance, right? So if I were to find the distance between the center, h comma k, and the point on the circle, which I've called xy, and it doesn't actually matter whether it's up here or here, anywhere on this blue circle, right? I know that distance is supposed to be r, the radius. So I'm going to argue that the distance is the square root of x minus the x value, so x minus h quantity squared, plus y minus k quantity squared. Or another way to write this is that r squared equals x minus h quantity squared plus y minus k quantity squared. Now notice it doesn't actually matter which of these is the larger value because I'm squaring them anyway. So even if h were actually the larger value than x, like even if these were reversed and I was looking at a point where the x value were smaller, it wouldn't matter because it's getting squared anyway. So essentially a circle with center h comma k and radius r has this formula, right? This is the formula for a circle. So you're using the distance formula, or you can think about it as using Pythagorean theorem, because this length, the length of this red line would be x minus h. The length of this red line would be y minus k. And so you could see that you're doing leg squared plus leg squared equals hypotenuse squared. Because fundamentally the distance formula and Pythagorean theorem are really the same thing, or two versions of the same information. So this is the generic formula for a circle, right? This is our formula for a circle with radius r and center h comma k. Now you'll see a slightly different version of this sometimes that's just slightly simpler. If your center is the origin, right? So if the center is the origin, because the origin is coordinate 0, 0, you'll see this as x squared plus y squared equals r squared, because it would be x minus 0 quantity squared, which is just an x squared, plus y minus 0 quantity squared, which is just y squared, equals an r squared. So those are the two formulae that you'll see for the equation of a circle. So again, this isn't technically a section in your chapter 10, but we're going to go through it just to make sure that we know how to find the equation of a circle. So that's the standard form for the equation of a circle. So again, standard form for a circle equation, right, is x minus h quantity squared plus y minus k quantity squared equals r squared, right?